Hey, what's up guys, my name is Cherno and welcome to another Sparky devlog. So, it's been a pretty busy week and I've managed to get Direct 3D working, so that's kind of the headline of today, but there are also some other kind of internal engine things that I've added just for debugging and general like system kind of stuff. So we're going to kind of go over them today, and but particularly the highlight is the Test 2D, which is our kind of used to be called test layer, but that was back when we didn't have 3D. So now, if you look in Sandbox, there are there are three tests. There's test 3D, test 2D, and then there's the deferred test, which doesn't actually work right now because I'm not working on that right now. Anyway, test 2D and test 3D. Test 3D still doesn't really work. Well, it still doesn't work with DirectX because there are a few things that I'm missing. Well, the big thing that I'm missing really, there are two big things that I'm missing. The first one is writing the actual PBR shader in HLSL. That's one thing I need to do. But then the other thing is cube maps, right? So there are no cube textures. There's no cube texture support for DirectX. If we look at texture cube, then it's largely unimplemented. You can see that it's still got all the OpenGL code kind of commented out, whereas of course the GL implementation for that is actually correct. All right, cool. So anyway, test 2D on the other hand does work, so we're going to kind of focus on that today. If I go into Sandbox is really all I care about. Let me just close everything over here. So we set the rendering API the same way, OpenGL, and if I just hit F5 to run test 2D, you'll see a few things that are probably new as well. So let's just run that and we'll see what happens. So first of all, we see our scene with our font rendering and just a few. This is just a few different tests as far as fonts go. We've got a mask on this, and we've got two sprites. One that just uses a color, and I probably show you guys the code, and you can see what I mean here. We've got one that uses a color, and that is this sprite over here, right, pink. And then there's the other one that actually loads in a texture, and that's what the kind of smiley face is. Texture filtering is set to nearest, which means that it's not going to try and do any kind of interpolation for the texture. It's just going to find the nearest pixel and snap to that, basically, so we get this kind of pixelated look. Basically, what I mean is the texture is like 8 by 8, but obviously we're rendering onto an area that's a lot larger than 8 by 8 pixels. So instead of using linear interpolation, which would look like this, we're doing basically nearest, which just looks for the nearest neighboring pixel and snaps to that, does not do any kind of blurring, any kind of interpolation. So obviously that looks quite disgusting. If we go back here to nearest, then you can kind of see what that looks like. Okay, and then we've got that, and then we've also got a mask on the whole thing, which is why you see this kind of, first of all, you see this kind of almost looks like lighting, like there's a light in the middle, and there's some kind of gradient, but you also have this kind of squiggle here that isn't part of the texture. If we look at the actual texture for, oh, that's right, I gotta also cover that. Anyway, it's a good thing I saw that, and I'll get back to that later. If we look at the resources and we look at TB, so TB is the actual texture that we're looking at. We'll have to zoom in. Okay, thanks Visual Studio. Anyway, we'll have to zoom in. What did I just do? I think I zoomed in, but it's gone now. All right, this is fantastic. Okay, there we go. How do I move this? I need to learn how to use this, except it won't let me. Okay, so anyway, you can see that that's what the texture looks like. And then the mask looks like, I'm not sure why that's not working, by the way, it's very weird. Usually it doesn't crash like that. The mask looks like this, right? So that's the mask. It's just like a squiggle, and you can see it's got like a vignette on it, which is why you get that kind of lighting effect, that gradient. But that squiggle is obviously what you're kind of seeing. So that's working, right? Because I feel like this is pretty much all you have as far as 2D goes. We have sprites that are either, there's no alpha sprites. That's probably something I guess you could kind of call, yeah, there's no alpha sprites, so we probably should do that, like partially transparent ones, and to make sure that we're kind of testing the blending. But this is a fairly reasonable 2D test because we've got a mask here, we've got a sprite with texture and without a texture, and we've got fonts, right? And of course, there you do use blending and stuff. You can see that how the glyphs will blend together, because like the quad for this script, for example, obviously the P is wider than the I, and it's all blending nicely. If I didn't have blending, then it would look very different. So everything's looking pretty good. That's in OpenGL. So if we go back to Sandbox and we switch over to Direct3D, then come on, you will see the exact same result. I mean, that's the expected result, right? It should be exactly the same, right? It should not be, you shouldn't see anything, like DirectX and OpenGL should look identical. You shouldn't be able to pick out a difference. If you do, then something's wrong, okay? So you can see that everything looks exactly the same, right? The other thing I added was up here now, whatever you set the window title to, there'll also be like a little pipe here, and it'll tell you what renderer you're currently using. That's kind of important as well, because I forget sometimes. And also it's good for debugging, because if someone sends me a screenshot, then I can see what renderer they're currently using without them having to specify anything. Control tab, of course, still brings up the debug menu, and now the debug menu is overlaid on top. That's also kind of a test of blending, I guess, because you can see how that's overlaid on top now, which is good. And what else? I think that's pretty much it, right? I don't think I've got anything else to add in terms of this. All right, cool. So that's graphics aside. You can see the Test 2D now works with Direct3D and OpenGL, which is very, very exciting. Okay, so the other thing you might have noticed is three things. You have this total allocated thing, total freed, and we have, as part of the actual, looks like part of the debug layer, we have an actual a size in megabytes here. And you might be like, what's all that? What's going on? Well, these two are simply added to the debug, to test 2D is just labels, right? But basically what I've done is I've added some form of memory management. Not really. Eventually Sparky will have proper allocators, and it'll probably allocate from some kind of pool of memory, so that we don't have to deal with actual memory allocations during runtime, which would be, during actual game time, I want to say. Obviously during loading and stuff like that, there's going to be plenty of allocations, but during actual rendering frames, playing the game, the ideal perfect situation is to have 0 allocations. Of course, that's pretty much impossible, but there are ways to kind of mitigate that, and you can do that by, having certain, like frame allocators and a bunch of other kind of memory concepts that we can talk about, where you actually already know, like the memory has been pre-allocated and you're simply kind of reusing it, and you know exactly where to get the memory from as well. So that kind of reduces a lot of the performance implications that come from dynamically allocating memory every frame, which is terrible. So we don't want to do that. We are currently doing that. Now, if we do run this, right, and we'll switch to OpenGL here. If we do run this, then you'll see that, first of all, we have the total allocated, which is the total amount of memory that we've allocated to date, right? So that is from the beginning of Sparky starting to where we are now. That's the total amount of memory that's been allocated, okay? Total freed is how much we've freed, right? So this is great for seeing memory leaks as well, but this thing up here is what we're currently using. Now you might be like, whoa man, you're using like 92 megabytes. Like this memory is actually what our application is using, not what any other like DLLs and nothing like that, right? This includes Sparky Core and anything that statically links into Sparky Core and the actual game, so Sandbox, that application. Everything else that might be in its own DLL has its own allocators, okay? And we can't really keep track of that memory. We can, obviously, you can see Visual Studio is doing it here, but this is actual game memory. This is the one we care about. That's kind of just overhead that we really can't do much about. This is actual memory, and you can also see that it is increasing every frame, and you might be like, well, what's going on with that? And at the moment, I'm pretty sure that like we are freeing it, obviously, so we're not leaking memory, but it looks like it's probably vectors, because the standard vector the standard template library's vector class likes to allocate memory liberally. So it is that's probably what's going on here without me spending too much time investigating it. It's probably vector. But yeah, I mean, obviously they could be fixed. I'm not really too fussed about that, especially in 2D rendering. We're not allocating huge chunks of memory either. But just something to be wary of. Obviously this number 4.18 meg should not increase. I believe we do allocate a little bit when we open the debug menu, and then we kind of free it when we close it. Well, total allocate is not going to go down, but that might. Okay, it's such an insignificant amount of memory though that we're not even seeing any change there. All right, cool. So anyway, that's how that works. If you want to know how that actually works, well, these are being fed in from something called the memory manager, and bytes to string just converts like a 64-bit integer of bytes into an actual nice string, so you can see how many megabytes or kilobytes it is, or gigabytes. The other thing actually that's probably worth noting is when you start up Sparky, you'll see some memory information. So we've got the physical memory and then the virtual memory of how much is available, and then total, right? So you can say this computer has 16 gigs of memory and 10 is available. So that's kind of just system information that I'll probably expand in the future. We also have the renderer information, and we have a bunch of stuff. We even got warnings for large allocations as well. This is good for detecting leaks as well and making sure that we're not allocating stuff. Keep in mind textures do get cleaned up. So if this texture was like a 500 megabyte texture, as soon as that gets sent to OpenGL, it gets deleted off the CPU, so or off main memory. So that would definitely go down. If that were the case. This texture is obviously tiny because it's like 8 by 8 pixels, and most of the pixels are the same. All right. Anyway, so that's how that works. And then if we look at what that actually does in a file called memory.h, this is basically the a bunch of overloads for the new operator and then the delete operator. So whenever that operator gets called, it goes through this, right? It actually allocates the memory, of course, using malloc. And in the case of new, what it does is it actually, and all of this stuff is really kind of temporary. You can see a lot of the code's been copied and pasted. Ideally, when I have time, I'll actually make it like an allocator class, and everything will go through like an allocate function instead of directly through malloc and all of that stuff. I just wanted to track memory usage, and I did this as fast as possible. So basically, what we have here is when we use a new operator, when we use the new operator, we request a certain size in bytes of how much memory we want. What happens actually is we allocate 1 byte extra, not 1 byte extra, but 4 bytes extra. Well, it depends on what the size type is. If it's running in 64-bit, this will be 8 bytes extra. If it's 32-bit, it'll be 4 bytes extra. And what will actually happen is we actually store at the beginning of this block of memory, we store how much memory we actually allocated. Now, C does do something, the malloc function does do something similar, because obviously when you call free, it needs to know how much memory to free. So it does do that automatically, but that is very compiler dependent. So I'm doing it myself. So basically what that means, as you can see here, is that we basically copy the size into that first kind of block of bytes, 4 bytes in this case, because it's 132. And that's it. And then of course the pointer to the memory we return is actually 1 byte ahead. So when we come to delete it, and we obviously increment stuff like total allocated and current used. And then when we delete memory, what happens is we get the beginning of the block of memory, which is the block minus 4 bytes. We figure out the size by just looking at that first size t, which is the first 4 bytes of the block. And then we can obviously see how much we freed and decrease the currently used memory, and then free the entire memory, which is kind of the beginning of that. So that's how that works. Eventually this will go through classes instead of being copied and pasted a bunch of times, obviously, but that is how that runs right now. We also assert if we try and only for arrays, it looks like, we assert if we try and allocate something very large, and usually that's good because occasionally you'll try to allocate you'll try and allocate a block of memory, and then the size is like an uninitialized variable, and it'll be like huge. So this is really easy for it to detect, because we should not be allocating more than a gigabyte of memory at a time anyway. So that's how that works. Cool. So that's the whole memory allocation stuff. We've also got the memory manager class. which kind of does something similar. Well, it doesn't do something similar, but it keeps track of all this stuff. So we have the system memory info, which is what, for Win32, it just queries, it just gets the global memory status and fills that array out. That'll have to be obviously implemented per platform, and then the memory stats just keep track of that. Okay, pretty simple stuff. And I don't think there's anything else to note here. Well, obviously, we do some string formatting stuff. And that's about it. So that's the whole memory thing and how it works. Again, right now it's really simple, and right now this isn't like a custom allocator or anything. You can see it's still using malloc every single time, and it's not really doing anything. I mean, it is custom a little bit in the sense that it's allocating an extra 4 bytes in Win32 to actually make room for that size, and it is storing extra data in that block of memory that you ask for. But it's not really it's not really a custom allocator. It's just kind of some extra stuff added to malloc. Okay, cool. So that's important because we can see how much memory we're using now, and generally we now can control allocations. So anytime we allocate memory, we can stick code in there that we want to run. There's actually one more thing that's useful for debugging that I kind of skimmed over, and that is you can actually call new with a file and a line, and then of course that will end up calling this new operator, okay? Which basically means that we now know what file and what line. Well, this is just basically some extra kind of text that we can put in here. It can be anything, such as file and line. But basically this will just make it so that if we do call new with that, since we do have a method for that, it means that we can see where that memory was allocated. So you can see large allocation and this should, okay, that's above a megabyte, in fact, not a gigabyte here. Well, it's not an insertion, it's a warning. But anyway, we can see what file and line we allocate from. So instead of having to obviously type in new with the file and the line every time, you can just make a macro called spnew, which is Sparky new, and then that just calls it with the file and line automatically. So that's why you'll see, and then sbdel is just delete, right? So you'll see in stuff like whatever, texture cube, you'll see like spnew everywhere, and that just means that we can kind of track those allocations a bit better. And that's basically the same as new, except it of course inserts that stuff automatically. So anyway, that's how that works. Really useful for debugging. We'll be definitely expanding on that more. It's just that I'm in the middle of graphics. I really want to finish this DirectX and OpenGL stuff so I can actually move on to developing the engine, because I feel like we're not really going forwards here. We're just kind of working on the features we've got now, which is important, but still it's a bit annoying. All right, I think that's all I wanted to cover. The last thing I wanted to cover, which is what I saw up here as free image, is now actually in the solution for Sparky. So it used to be that we just used the freeimage.lib and we had to use a DLL. Now we are statically linking free image, which means there is no DLL required. And also we've got the source code here. The major reason and the major motivation that I wanted to include this stuff here is because I wanted to take advantage of some of the utilities that free image had. For example, in free image, you have something like swap red blue, which is actually part of the utilities package, which wasn't in the original DLL that I found online. So you could either compile a DLL yourself, and I thought, well, if I'm going to have to compile free image again by myself, I might as well just include it in the project. So I did that. This was a bit annoying to set up because there are a lot of files. I didn't compile everything. OpenEXR, there is so much stuff in here that I'm just not compiling, because it's huge and it's a pain in the ass to compile. So not doing that. But anyway, we've got TIFF, we've got PNG, we got all that stuff. If you look at plugin.h, and also means we can add plugins, by the way. So in plugin.h, or rather in plugin.cpp, I guess, you can see all the plugins that we support. So we're not supporting EXR or RAW. We don't really need those. We are supporting all these though. So JPEG, bitmap, and all PNG, all the kind of stuff that you would expect. TIFF, tar, Targa, yep, TGA, right? We're supporting all that stuff, and that's really all we need. GIFs even, a lot of stuff, DDS as well. All right, so anyway, that's how that works. So it's now in here, and free image is quite large as well. So there's a lot of files, there's a lot of extra files. I didn't include the OpenEXR files in the solution or anything, but still, I think the solution count has gone up by about 300 or so files. So there's 791 files now in the solution, and many of them are free image. I think most of them are free image. There's box 2D, free image. Yeah, lots of free image, bit of free type, Gorilla Audio, LibreVorbis, Sandbox, and then the rest is Sparky Core, I believe. It's quite a lot of Sparky Core as well. It's about 250 files. All right, anyway, that's it. That's what I've done over the past week. Quite a lot, as you can see. But hopefully this week, I'm actually going to focus. So last week was me focusing on getting Direct 3D up and running. Last devlog, I believe it wasn't running at all. So this is definitely an improvement. But yeah, I'm going to focus on getting, now that I've got 2D running, I'm going to focus on getting 3D running with Direct 3D and OpenGL, and then I'm going to go back and probably start extending the engine. Next on my list, I think, in actual engine work is probably stuff like post effects. I really want to get them down so that I can start adding stuff like bloom and screen space effects like screen space ambient occlusion, screen space reflections, to an extent probably. What else was I got? Well, yeah, all the kind of post-effecty effects that come up. HDR rendering is something that I need to add as well. That was actually the next thing I want to focus on. And proper tone mapping and getting it to maybe adaptive exposure and a lot of kind of stuff that are more effects based, because PBR is kind of done. Oh, I also need like good shadow support and light map support like in the engine. Anyway, a lot of stuff. Lots of work. Adding some kind of scripting language, and I'm trying to decide between Lua and C# at this point. C# requires quite a bit to actually get running, but I do prefer it to Lua, so we'll see. I mean, I'll probably end up adding Lua just because it's easier, but we'll see. Alright guys, thanks for watching. If you enjoyed and you want to support Sparky, then you can head over to patreon.com/thecherno and become a patron, and that basically just, yeah, supports me in my development of Sparky. You get access to some extra Sparky code that not everyone will see. As soon as I finish Direct 3D, so as soon as Sparky runs correctly in like all of Sparky, including 3D Sparky, PBR Sparky, runs in Direct 3D and OpenGL, I'll be making an official release on GitHub. And I'll be pushing all the code to GitHub, but if you want it before that happens, it should happen this month, but you do get access to a more frequently updated repository of Sparky code, if that is something you desire. All right, guys, have a good week, and I'll see you next time. Goodbye.